Alright, gang, the last video for section 1.5 is about even and odd functions. And if you remember, earlier in the chapter when we were talking about symmetry, we had some tests for symmetry. If you plug negative x in and you simplify and it's the same as it was to begin with, then it was symmetric about the y-axis, and we had all those tests. And I said, it's going to seem kind of daunting at first, but when you recognize certain things, it becomes very, very easy to determine whether or not a function is symmetric about the y-axis or the origin. And I even put a little caption up there, and I hope you noticed it, that anytime you squared something, that negative disappeared and it remained the way it started. And so that's kind of where we come into this idea of even and odd functions. Okay, a function is even if for each x in the domain, f of negative x equals f of x. In other words, when you plug negative x in, you still end up with the same equation you started with. And an odd function, for every x in the domain, f of negative x equals negative f of x. Okay, and the only reason we're really interested in whether a function is even or odd is for the symmetry that we know the graph will have. Yeah, so in section 1.4 we talked about symmetry, and the pattern was that whenever you plugged a negative x in, if it was squared, it reverted back to what it originally was. In fact, if you raise it to any even power, it's going to remain the same. And even powers result in an even function. All right, so that's why I use even or odd to describe functions, because we know now that an even function is symmetric about the y-axis and an odd function is symmetric about the origin. Okay, to determine whether a function is even, all of the x terms have to have an even power. All right, if they don't all have an even power, then it's not even. And to be odd means all of the powers on the x's are odd. And again, even is symmetric about the y-axis, odd is symmetric about the origin. So we're going to put this to the test and determine just from the equation whether or not a function is even or odd, meaning whether or not it's symmetric about the y-axis or the origin. So here's our first one. Y equals 3x to the fourth minus 2x squared plus 3. What are the powers on those? We have a 4, we have a 2, and then we have, I don't know what. Okay, this function is even because when you don't have an x value, that itself is even. I like to tell my students to think about it like this is x to the 0, and 0 would be considered even because anything to the 0 power is just 1. So essentially we have 3 times x to the 0, which is 3 times 1. So 4, 2, and 0, they're all even. How about this one? Okay, we have powers of 4, 1, and 0. And because there's an odd and an even power, it's neither odd nor even. All right, let's try a couple more. That one here, we don't have a power at all. So you should know that's essentially x to 0, meaning that it's even. And if you think about what that graph looks like, y equals 3 is just a horizontal line. So if this is my y-axis, this horizontal piece is going to be equal to that horizontal piece. They're going to be a mirror image of one another. And an even function is symmetric about the y-axis. Lastly, we have a power of, oh, I don't have my circles on there. We have a power of 5, a power of 1. All the powers are odd, therefore function is odd, therefore it is symmetric about the origin. So now you'll be able to tell the symmetry of a function based just on the equation, and like I said, it's pretty darn easy. That is the end of this video. Adios.